Welcome to The Explainer. You know, every time you stream a movie, fire off an email, or jump on a video call, you're tapping into the cloud. But here's the thing. Behind that seamless digital world of ours, there's a massive hidden energy cost. So today, we're going to look at how a really clever AI is helping to make that cloud a whole lot greener.
So, what are we really talking about when we say the cloud uses energy? I mean, how much are we actually dealing with? Let's try to put a real number on it.
Okay, look at this number, 95.52 kilowatt hours. This research found that's how much energy some older systems can burn through to process just 115 simple computing tasks. That is a huge amount of power for a pretty small job. So, the big question is, where is all that energy going?
Well, the answer really lies in understanding what the cloud actually is. It's not some fluffy thing up in the sky, right? It's very, very physical.
You see, every single digital thing we do gets processed in a real physical data center. And these are gigantic buildings just packed with servers, running 24/7. Powering all of them and just keeping them cool consumes an immense amount of electricity. And that creates a major challenge. How on earth do you manage all that power efficiently?
But managing all this energy isn't straightforward at all. Data center managers face what you could call the Goldilocks dilemma. It's this constant struggle to get things, well, just right.
And this quote just nails the problem. To make this super clear, let's use an analogy. Think of a data center as a massive, bustling restaurant kitchen. Your video stream, your file upload, that's a customer's order. And the servers? They're the chefs, ready to cook it up. Now, the technical term for this whole process is resource provisioning, but in our kitchen analogy, it's basically the head chef trying to figure out exactly how many cooks and how many burners are needed for the big dinner rush. And this is exactly where that dilemma kicks in, because if you get it wrong, you've got big problems. On one side, you have too cold, or under-provisioning. You don't have enough chefs, so customer orders get delayed and your apps feel slow and laggy. But on the other side, you've got too hot, over-provisioning. Now you have way too many chefs just standing around doing nothing. You're wasting salaries, and in a data center, you're wasting a truly massive amount of energy and money.
So, getting this balance perfect is incredibly difficult. But this research we're looking at proposes a new, much smarter way to manage the kitchen, and it's a three-step solution.
They call it the Effective Resource Provisioning Mechanism, or Eff-RPM for short, and it's designed to get that Goldilocks balance perfect, but automatically.
It all works in three distinct stages. First, it pre-processes all the incoming orders. Second, it clusters them into logical groups. And third, it provisions the perfect amount of resources to handle them. Let's break that down. All right, step one, pre-processing. This is all about organization. It's like having a great front-of-house manager. It takes all the incoming orders, it cleans them up, getting rid of any errors or junk requests, and then it gives each one a unique ticket number. It's all about making sure only valid, clean orders actually make it to the kitchen.
Next up is clustering, and this is where the system starts getting really efficient. It groups similar orders together, so like putting all the steak orders on one ticket and handing it to the grill chef. And it does this using a pretty smart algorithm called enhanced genetic k-means.
And finally, we get to provisioning. With all the orders cleaned up and grouped together, the system assigns the perfect chef to each task. And this is where the AI brain of the whole operation really takes over.
See, this is the really cool part. The system doesn't just react to orders as they come in. It actually predicts them before they even arrive. So, the brain here is a type of AI called a Hybrid Optimal Convolutional Neural Network, or HOCNN. What it does is analyze all the past order data, like when was the lunch rush last Tuesday? What did people order on Friday night? And it uses all that to accurately predict the next big dinner rush. It knows when to expect a flood of orders.
And once it has that prediction, another algorithm called cuckoo search optimization kicks in. It takes the HOCNN's forecast and creates the most efficient plan possible. It's like the head chef getting a perfect prediction of the night's orders and then creating the perfect staff schedule, making sure not a single chef or a single burner goes to waste.
Okay, so that's the theory. An AI manager that perfectly predicts the dinner rush and staffs the kitchen. It sounds great, but does it actually work? Let's take a look at the results.
The researchers put this Eff-RPM system to the test against several existing methods, and they used that same set of 115 workloads we talked about at the beginning. So, how did it stack up?
Well, the results are pretty striking. The older methods used 95.5 kilowatt-hours. The new Eff-RPM system, only 76.5. That's a 20% reduction in energy use. That is a massive saving, just from smarter allocation.
And of course, saving energy translates directly to saving money, a lot of money. While the existing methods cost over $429,000 to run, Eff-RPM did the exact same work for just over $236,000. It literally cut the operational cost by almost half.
But it wasn't just cheaper and greener, it was actually better. The SLA violation rate, which is basically how often an order was late or got messed up, was lower. The delay was shorter. And maybe most importantly, resource utilization was nearly 89%. That means almost all the chefs were busy working, not just standing around wasting energy.
So, why does all this matter beyond the walls of a data center? Well, because this efficiency isn't just some abstract number on a chart. It actually powers the services we all rely on every single day.
This kind of smart resource management is what allows for smooth, interactive online gaming without all that annoying lag. It's what enables real-time financial trading, where every single millisecond counts. It makes the web apps we use for work faster, and it makes the cybersecurity platforms that protect us stronger. It just makes our entire digital world run better.
Which brings us to our final question. We often think of AI as this thing that creates new, power-hungry technologies. But what this research shows is that AI could also be one of our most powerful tools for making the technology we already have drastically more efficient and more sustainable. It's not just about building a smarter cloud, it's about building a greener one too.